Hey everyone, my name is Rich Horace. I'm the organizer of LA Elastic Music Group. And basically, tonight we're going to have a couple guys from Elastic present on new ways to get data into Elasticsearch. And we're going to also talk about some of the announcements from February's user conference. Did anyone here go to the Elastic conference? It was definitely a lot of good stuff presented, and a lot of new logos that you see from the new stickers here. But I am really looking forward to this presentation. But the way I like to do my meetup is I like to have everyone go around the room and introduce themselves. Let us know what you're doing with Elasticsearch. If you're using the whole dedicated stack, how long you're using it, it's introduction. Just do a quick introduction. So about you.
My name is Joshua. I am a Ruby on Rails developer. I've been developing quite a year. I just used Elasticsearch. I just found out about it the first time a couple weeks ago. I'm making a practice app. I thought it was really, really cool.
My name is Jason Pitt. I'm a software engineer for Chile. It's an organization. We're using some of the APIs on top of it to access our data. It's really interesting from a personal project standpoint. Do some things with Elasticsearch as part of the data input and data pipeline for natural language analysis. It's really neat. The new network graph was released. It's really cool. So I'd like to do some more stuff with that, map relationships, natural language, and do articles, and different articles. I'm 211 on that. 211.
Hey everyone, this is Wayne. I'm a software engineer. I use Python and I use Elasticsearch for personal auth data and working on the analytics. It's great for you guys to
Hey, I'm Bobby. I've only slightly touched Elasticsearch. I just by looking at the features, it looks something like it's really interesting, something I want to dig a little deeper in.
My name is Alfred, full stack developer, mostly in Python code. I'm actually at an angle, just like kind of sitting and see what you guys kind of say and talk about. I really touched Elasticsearch a bit, but yeah, mostly here just to see the presentation.
My name is Johnny. I'm a software developer. Now we're using Elasticsearch. So it's just
Bigger, accessibility. I need a little bit of the rest of it. Just a little bit of information.
Hi, I'm Henry Pack. I just actually joined Elastic as an SA in the Los Angeles area, Southern California region. So if you guys have any questions, like I said, engineers are going to start talking about it, what's the mind, feel free to contact me or talk to me afterwards.
Hey guys, my name's Dan. I'm CTO at a startup called FAPL, and we just started incorporating Elasticsearch to our search functionality, and just looking for new ways to incorporate it into our stack.
Hi everybody, I'm Brandon, also at FAPL, full stack engineer, and I'm looking to learn more about Elastic so I can work with it on the stack as well as in my personal projects.
Hi, my name is John Nolan. I'm with Board Runner Studios. Elasticsearch is something new to us, so it's something I'm trying to get up to speed on.
Hey, my name is William. I'm a system engineer at Qualifier. We use Elasticsearch for logging and for stored text messages, searching for text messages. So I'm not directly involved in the development of it, but I need to be able to support it. So just kind of learning more about Elasticsearch to see how other people use it and share more stories.
I am Karthik from Verizon Distributed Services. Some of the teams in our company use Elasticsearch for things such as DDoS protection, layer 7 attacks, and stuff like that.
Hi, my name is Carl. I'm with USC. There's a master program for data science and spatial data science. So basically, it's a lot of data science stuff.
My name is Ed. I'm right now working on an app for the Chinese market. So we're planning to use Elasticsearch to search for Chinese text, and I hope it works. I'm not familiar about how it works in Chinese.
Hi, this is Ruby. I'm working with Symantec. We've been using Elastic for about 3 years now. And I work on the platform we are doing.
Hi, my name is Cesar. I work at UCLA, and we're doing more of these software. Hi, my name is Benjamin Islam, CTO at Outline. We've been deploying Elasticsearch in production for a little over 3 years now, since we're deploying it.
Hi, my name is Josie. I'm an IT consultant learning about Elasticsearch.
Hey, my name is Hudson. I'm a software engineer at Spider. We use Elasticsearch mainly for reports and logging.
EG also from Vesves and same reports like
And then my experience with Elasticsearch and Logstash was back before Logstash was suggesting Elasticsearch as the primary backend. But right now we use it every day for the last few years in production. We do all our application logs in there. We don't do the deployment without seeing the metrics of how the application is performing once it goes into production.
Hey everyone, my name is Suyo Grau. I work at Elastic as an engineer. I primarily work with Logstash, but I do plenty of training, and we had training this week in LA, so that's what we're here. Thanks for coming. We're going to talk about a bunch of stuff that happened in the user conference in February, and also new ways to get data into Elasticsearch. So my partner in crime is Ryan.
Hey, Ryan with Elastic, based out of New York. And on the education team, so I do a lot of the training, prepare a lot of the material that we do when we go from city to city and deliver the trainings. Prior to Elastic, I was a Java engineer for about 12 years, and companies minus ago used Elastic and the Elastic Stack for both logging and full text search in the applications I built, and I liked it so much that I joined and I'm here now. So definitely a fan. Priority.
All right, and this is a special meeting because Elasticsearch, Elastic is in town and training to try to do some type of meetup. So the regular meetups is the third Wednesday of every month. Next week is going to be Hollywood, Ticketmaster, and this year what I started doing was East Side, West Side. So this month will be East Side, next month will be West Side. We go back and forth. And you guys can travel back and forth across the city if you want, but I'm really trying to build up a strong user base in Los Angeles. And that means not just always doing all our meetups in Santa Monica or Culver City or on the West Side. So I think I might have a speaker for next week, but definitely come up and join the fun. Then we also have the third week of May. I don't think it's not the 20th. So most likely, we're looking at writing games over here and also in Cinnamon area. So definitely check out the meetups. I have every meetup scheduled for the rest of the year. So feel free to sign up. Also, people mentioned personal projects. I would love to just do a meetup talking about personal projects with Elasticsearch. I have a few that I want to kick off this year. I think I'll finally have time to do. So, if you're interested, it doesn't always have to be with business, but just any personal things you guys do with Elasticsearch, I'd love to have a meetup around that. So, keep it in mind. I'm always looking for speakers.
Okay. My other arm is broken here. It's fixed now. Okay. So, as Rich alluded to earlier, we being Elastic, had our annual user conference. It's held out in San Francisco. It was in about the middle of February, and we had a bunch of announcements about the Elastic Stack and stuff. So we thought we'd give you a quick recap on that, and then Suyog is going to come up and going to go into one of the new features we announced there, and we're going to do a live demo. He's going to show you some stuff. I'm going to ingest data from my laptop into his laptop. Hopefully, the demo gods will be good to us today. So, just in case everyone's not clear, because I think there were heard a lot of people who are either just starting or new to the Elastic Stack in general. Commonly, prior to this, you might have heard it called the ELK stack, ELK. It sort of was a self-named thing because Shai, our CTO and founder of Elasticsearch, never wrote Elasticsearch to be used for logs. He just wrote it to be used for full-text search. And then we had Rashid and Jordan came along, and each independently. Jordan wrote Logstash, Rashid wrote Kibana, and they sort of became a nice, loosely coupled set of tools that work well together for the logging case. Well, as all three of those open source projects came together under one company called Elastic, we started to add other products to the family, such as Beats. We have a sticker. Beats, which is lightweight log shippers. So there are a bunch of shippers. Back at Beat, which looks at packet data on your computer. Top Beat, which does like CPU process information. WinLog Beat, which can listen to Windows event log messages. File Beat, which can tail files, etc. We also have our cloud, which used to be called Found, and that was Elasticsearch as a service. So the whole ELK did not really work well for us anymore. So instead of the ELK stack, we decided the Elastic stack makes more sense as we have all of our new icons here and logos, and as we hopefully add more to the open source stack as things go on. So new logos and everything, but the ELK is still there, but we have a DNC now. So Elastic stack. And we have hot stickers too. So on the Elasticsearch side, what's been going on with it? So Elasticsearch started out in the 0.1 kind of era for a long time, and when it graduated to 1.0, it was a big step. And then last year, 2.0 came out, and that was another big step. And a lot of that was sort of just getting a lot of features in, we moved from facets to aggregations, we put in backup strategies in a snapshot restore in 1.x, a bunch of stuff like this, but Basically, what we've been featuring, focusing on lately is a lot of resiliency, stability, and sort of hardening of Elasticsearch itself. So you hopefully see a pattern in our release notes as they come out, that we're doing things to, for example, really drive down the amount of heap usage, Java heap, that Elasticsearch needs. This has been done with block values and a bunch of other features we have. And our goal is to eventually make it essentially so, like, long term, the Java heap is not a scaling factor at all for how much data a node can support. So the team is working very hard on that. And also a lot of stuff with security. So things just such as like out of the box default settings to a new scripting language that's coming out called Painless that is completely sandboxed. Has a lot of sort of checks in it to make sure that you don't accidentally shoot yourself in the foot and get yourself into a scenario where a document that has the right kind of data in the field or missing data sends something off into an infinite loop or something like that. And then we've done a lot of work on the security side in our commercial product line for things just past username and username password authentication, but down into like role-based authentication and field and document level security. Stuff that's really, really hard to do in search. And actually Igor and Jay, both on the team, did a wonderful talk about that at Elasticon, and all of the Elasticon videos are now up online. You can watch for free. So if you're interested in how you do that secure search, they have a talk up on there. So then next up with Logstash. Logstash, has really grown over the years to just be a amazing Swiss Army knife. Typically people use it with Elasticsearch, but there's many people who use it and don't even use Elasticsearch because you don't have to. And it's also wonderful when you want to ship data to multiple sources. So not just Elasticsearch, but let me ship my data parallel into S3, into Elasticsearch, and maybe somewhere else. So Logstash is got the very, very big plugin architecture, but once it gets into ES, we have all the other features that we have coming along with it in our commercial pack. And Logstash is basically going to be we have clustering capabilities, automatic file reloading, and a bunch of other features that Suyag, who's on the team and much more intimate to it than I am, tell you about. Basically trying to make it so that people who are running very large Logstash deployments have a better way to manage those, config management, etc. So maturity of it. And I sort of skipping the pipeline stuff because Suyag's going to talk a lot about that. So Kibana is the UI on top of Elasticsearch. And recently, Kibana sort of became, it used to be that Kibana did one thing, and that was visualize the data on top of Elasticsearch. Kibana is now essentially our UI platform, and there are plugins for Kibana. So the move to this makes it so that you can come along, write your own plugin, leverage a lot of the Kibana visualizations, frameworks, etc., but then take the data and represent it in whatever way you'd like. An example of that is our Marvel, which is basically visualizes the monitoring data of Elasticsearch and puts it in a way so that it's like a dashboard for the health of Elasticsearch. And Rashid recently wrote Timeline, which is another Kibana UI plugin to deal with time series data. Kibana now has a nice login screen if you are using it with an authenticated version of Elasticsearch using our security plugin currently called Shield. And like I said, we've been listening to the community a lot in regards to the priority of features that people want to see in, or features that we had to, for the sake of time, getting the 4.x line of Kavana out, that we missed some stuff from 3, get the data back in there. Beats is the newest member to the Elastic family, and like I said, Beats is also open source, and it is all written in Go. And there is a common library called libbeat, L-I-B-beat, and that's sort of like the commonality pieces that are the same and leveraged across all the different beats. And the first beat was packet beat, which basically you can fire up on like your laptop, tell it what interface and what port to listen to, and then it will basically like Wireshark capture those packets, and it can do high-level inspection on them. So it will take, if it sees HTTP data, it's going to take that HTTP data and turn it into a JSON document describing the status code, the path, the request, the HTTP, was it a GET, a put, a post, what were the query parameters, how many bytes in and out, what were the headers, put that all as fielded data in a JSON document, and then ship it. And you can ship it either to Elasticsearch, or you can ship it to Logstash. And that pattern is there for top beat, packet beat, file beat, min-log beat. We have a Docker beat now, and a few others. So we're very excited about these because they're really easy to write, especially if you're a very good Go person. And we're hoping that a lot of people will have specialized data, and this is an easy way for them to collect that off of a lot of resources. Okay, so we used to have Found, which was Elasticsearch as a service. So sign up for it, log into the website, click the button, wait about 30 seconds to 1 minute, and you have an Elasticsearch cluster up and running that you can send data to. And if you want to upgrade it to a new version, you just pick from the drop-down, new version, and say go. And it's automatically snapshotted every 30 minutes for backups and all this fun stuff. We now, Found is now called Cloud. So we have Elastic Cloud. But we have a new version of Elastic Cloud called Cloud Enterprise. And what Cloud Enterprise will do is essentially you can bring all that point-and-click UI management, automated spin-up clusters, point-and-click to upgrade, to install Shield, to set up Kavana, all of that you can install on-premise in your enterprise. Or you can take it, and if you have a specific cloud vendor that you like or already have an investment in, you can set up Cloud Enterprise over there. So you can sort of take it to whatever cloud you like, or run it within your own data center. So we're really hoping, very excited about this one because it really helps take a lot of the administrative work away from you and your organization, especially if you're planning on needing to spin up maybe 10, 20, 30 clusters for different teams, different environments, and different projects, and make that very easy. So this is what I said already. The goal here, if you're already in the current cloud that we offer is run out of AWS. And Cloud Enterprise, like to say, you take it, make it wherever you like. Okay. So first, some people ask, well, hey, Elasticsearch is open source, but now you're starting to have all these plugins and everything. So are you going to make, since you just made an enterprise version of cloud, are you going to make an enterprise version of Elasticsearch and start to not make it open source? And sort of a promise here, right, that Elasticsearch, there will never be an enterprise version of it. It's going to stay the way it is, open source, etc. But we will continue to make add-on plugins and additions to it that are enterprise version. So like the security one, or like our new Graph API that was just announced and is available in our alpha release. So also, we had all these different plugins. We had versions of Kibana, we had a Shield plugin for security, we had Marshal for monitoring, we had Watcher for alerting, we had log stash version. So it was a little bit cumbersome for people to like worry about installing these things, managing versions, etc. So we decided to come out with the concept of a pack. And a pack, we have X pack, and a pack is essentially a grouping of plugins that you can just download one file, install it, and then you just have to set settings whether you want the individual plugins within the pack to be enabled or disabled. So we're hoping this is going to help take away a lot of the burden of administering a lot of the extra add-on pieces and parts. All right, so we'll talk about this. Okay. Would you want to take over here, or can we keep going with this? Okay. So, the next major release of the entire stack, Elasticsearch, Kibana, everything, is going to 5.0. We're basically converging there. No, you did not miss out on a secret Elasticsearch version 3 and 4 that we only, tweeted about to certain people or something like this. Essentially, we have maintained, if you go to our website, a fairly large compatibility matrix of, okay, this version of Kibana works with this version of Elasticsearch. Logstash works with this version, Watcher works this way, Beats works this way, and we were getting a lot of feedback that keeping track of all that was becoming very cumbersome, not only internally, but especially externally for our user base. So we decided to sort of sync the version numbers across the stack, so it's very obvious for people what's compatible with what. So, excuse me, whenever you do something like that, it's like, what version are we going to use? Well, Beats were on version 1 dot something. Logstash and Elasticsearch were on version 2 dot something. And Kibana was on version 4 dot something. So, the only common denominator we could have was that everything now immediately becomes 5.0. So that's sort of the rationale there. We didn't miss anything. Yeah.
So then you're going to use the subversions to track the changes to individual platforms. So the major version will be the same compatibility, and subversions for updates.
Okay, so the question was, are you going to use the major version for compatibility and the minor versions for updates? I think is that what you said? Yeah. Oh. So the major versions are, when we just generally speaking, major versions in any of the current products we have, always is where we say we will introduce a breaking change. We deprecate, and then we tend to remove features in a major version. Minor versions are incremental functionality and are backward compatible. In regards to across the stack, right now the versions are being locked on minor versions. So
going forward, are you going to, so you're synchronizing versions?
Yep.
Instead of going forward, are you going to use those minors? Because I assume all these, we have to develop at the same speed. So are you going to use your minor versions to track, there's been a change in this particular level? Every time release is always times.
yes, that's the way it's being done.
Patch. It's always. So,
So if we are at 5.0 and this platform in 5.0, it's going to be 5.0.com for the entire stack. Some products might not have any changes, which is still fine, but we'll still use it. So we just want to make this, we don't want to make this a matrix hell, right? So just everything is the same. You can choose not to upgrade to a version because you don't want any changes from there. But from as a vendor, we will keep releasing versions, right?
Okay, so when it comes time to vendor release these things, what features they have in, etc. Our philosophy is that we want to try to avoid something like this, right? Where the user, right, people are not really happy until we assemble all the pieces and parts together. Because you can't really, these pieces and parts are not usable to you until you actually get to this phase. What we'd like to do is try to make it so that we actually deliver incremental, like functionality that's usable with the goal that we'll eventually get to what everybody is hoping for, right? A good example of this is about a week and a half ago, I think it was, 2 weeks ago, Elasticsearch 2.3 was just released. And in 2.3, we backported in a feature that was a master that was the re-index API. So Elasticsearch finally has an API endpoint you can call to re-index your data internally. This is probably, when we launched it and the tweets went out, I'm sure I heard like little people like standing up from their desks all around the world like saying, yes, right? We know it was a necessary thing. It's not like the full-blown version that we are going to have with the re-index API. There's a lot more features planned for it. But we knew it was really important to get it out sooner rather than later because a lot of people were needing to do this and manually doing themselves. So that's sort of one example where we wrap it up as soon as we can to where it's usable in one way and deliver it. So our hope is that we can do that with a lot of things as time goes on. Okay, so here I'm going to turn it over to Suyan, and he's going to talk all about this, one of the other new features of 5.0, and it's the ingestion pipeline and how that's matured in our sort of thought process behind some additions to it.
Ingesting data into Elasticsearch, it's gone through an evolution. It's gone through different stages or different products. So at very first, in the company when Elastic formed, Logstash was way before Elasticsearch, and Jordan Cecil created Logstash in 2009 because at that point he was a system administrator and he was pretty frustrated because he could not get logs from all the servers and to be able to analyze it and so on, so he wrote Logstash. And then Logstash itself joined Elastic at about 2 years ago. So Logstash became one of the ways of ingesting data in Elasticsearch, but it was not the only way, but it was one of the ways to do that. Then Logstash Forwarder is another project that Jordan created, and it was mostly because he was seeing that a lot of users were complaining that Logstash was heavy and because it's written in Ruby and it runs on Java, it runs on JVM. A lot of users were deploying it on small boxes, AWS, micro boxes, and so on. And they were like, hey, Java is too heavy for me, I'm not going to use it. So Jordan wrote another tool in Go, and this is called Logstash Forwarder. Logstash Forwarder is the lightweight resource-friendly shipper that takes information from all your servers and can send it to a centralized server, which is Logstash. So he wrote that in 2012, and it became super popular. At the same time, in 2013, Monica and Tudor, who were in Germany, they created this software called PacketMe.
And Packetbeat again is a very lightweight, resource-friendly way of analyzing packet data. So what it does, it intercepts your request response and the network traffic in your systems, and it can parse the information and send it to Elasticsearch. So you get information like how many bytes were transferred from my application to the server, and what is the topology of the network, and who's trying to ping my server, and so on. So all kinds of good information that is happening in the packet layer. So we go down to the packet layer, and this is great because you don't have to turn on anything, right? So you just have to install Packetbeat, and it passively sniffs the network, the network layer to get information. So you don't have to turn anything on. So it records information, and it's very, very resource friendly. So it's not going to add more stress to your environment. So it was really popular, and Packetbeat joined Elasticsearch in 2015, and that's how we transformed Packetbeat into Beats, which is a generalized way of sending data from multiple parts, and then this became the way forward for lightweight resource-friendly users. So it kind of moved from Logstash being the big centralized place, and now with Elasticsearch, Beats became the platform, and Brian was talking about LibBeats, which is basically a framework so that you can, as a community user or a community developer, you can go and write your own custom beat, right? For example, to parse some data, and then use that to send data to Elasticsearch. Right. And then very, very recently, with 5.0, we've introduced a new feature inside of Elasticsearch called ingest node. So what ingest node does is it helps you when you're sending information into Elasticsearch, it helps you analyze it, it helps you parse it and tokenize it and things like that. And you could do this with Logstash, but for many, many use cases, this is what people ask us. It's like, I just want to get data into Elasticsearch, and I have a file, and I just want to send data into Elasticsearch. I don't need Logstash. It's too complicated for my use case. It's a good piece of software, but for me, it's not yet the right fit. I'm not at a point where I want to use Logstash, right? So you want to make sure that we introduce the right tools at the right time for the users, right? You don't want to overburden them with this is how you do it. So the Elasticsearch and the whole company, we believe that every product should work independently, and when we're using it together, they work really, really well. So this is the philosophy, right? You can still use Elasticsearch without Kibana, Elasticsearch without Logstash, without Beats, and you can write your own custom ingestion pipeline and so on. But so the point was that there was a need from users saying that I don't want to learn Logstash configuration and not yet, right? I'm not ready for it. My use case is really, really simple. I have a bunch of files. I want to send that data into Elasticsearch. And then hey, what's the point of sending data into Elasticsearch if it's not structured? And the more structured data is, you're going to get back richer results, and you can do more aggregations and analysis and so on. So it'd be nice when we send data into it, we could also parse it, right? So Logstash was really, really good at it. So what we did was we took all the concepts from Logstash, the filtering part of it, which is basically the processor, which takes unstructured data and converts it into structured data, right? So we take a log line, for example, which is a blob of text, and then we identify patterns, we identify fields in there so that we can extract that information. And Logstash was really good at it. So we took those concepts, we took the same existing library, and we rewrote them in Java, and we call this ingest node, right? So the point here is that at some point in the future, you will be able to kind of migrate from Logstash to ingest, and from ingest to Logstash back when you're ready for Logstash, right? When your use case is a little more sophisticated, a little more complex, you can go back and forth. So this is what we want to provide, because the processing features in the ingest and the processing features in Logstash are kind of have one-to-one mapping. It's really anomalous. So when all this was there, so a lot of people who already use Logstash or you're using Logstash in the current use case, like, so why should I use Logstash now, right? Logstash is still a very, very important part of the stack, and it's going to continue to be an important part of the stack because, as Ryan was saying, there are a couple of really, really important points here. Is that multiple outputs and inputs. Logstash supports ingesting data from JDBC and S3 and all kinds of different data sources, and then it can take all that and send it to different outputs. Elasticsearch can be one such output, but it does not have to be just that, right? You can send this to Elasticsearch, and then you can send it to S3, to HDFS, and then to Kafka, and so on. So this is really, really important for us. Then there could be complex pipelines. A lot of users of Logstash write big configurations that have very sophisticated user data flows. They say, if my log line, if it has response code 200, then send it to Elasticsearch. If it is 404, send it to PagerDuty. If it is, if it is Apache logs, send it to S3 for archiving, and so on. So you can write conditional logic. It's almost like a programming language. You can design the data flow, everything in Logstash. So this is again a very important point, and ingest does not have it yet. So Logstash is the way to go if you have a very complex data flow architecture. And finally, Logstash does really well in sending events to persistent queues like Kafka and Redis and so on. So how many people here know about Kafka? Right? Yeah. So what Kafka is it's a messaging system. So it's a distributed message broker. So you can send a lot of events or log data into Kafka, and Kafka can store it as a staging area before you're ready to process it into Elasticsearch. So you can get your data out of all your machines as soon as possible, and then send it to a centralized messaging area, which is kind of an intermediate storage area before it gets into Elasticsearch. So Logstash has native connectors to Kafka and Redis and so on. So again, that's another important reason to use Logstash with ingest and so on. And then there's also the fact that Logstash is a very API-friendly platform. Again, it's another platform, so you can write your own extension to it. So you can say that here's my proprietary data, and I don't have I have my own internal APIs, and I want to connect Logstash to it, right? So you can write your own Java and Ruby code to do that. A lot of people really like the flexibility because it's pretty easy to write an extension into Logstash. Right. So as I said, we want you to be able to go to ingest very easily, get your data into Elasticsearch, but at the same time, as your needs grow, we want to be able to go back into Logstash and use the more complex architecture of Logstash. So, here's one of the ways that we were using Logstash. We go from a file to beat, which is a file beat, and then file beat writes to Kafka, which is the messaging system which holds all the logs in an intermediate place. And then Logstash used to do processing, and it used to do grok and GOID lookup, enrichment, and so on. And then finally we send all the data into Elasticsearch. So we were saying that this is a fairly complex architecture, and maybe when you're starting out, you don't need all this extra architecture. So you want to simplify things. So that's why with the ingest node, you can go directly from this, and Elasticsearch, right? So that's why you can kind of get away with the message broker and Logstash if you don't need it. If you need it, there's an option to use it. So we want to make sure that the simple things are simple. So again, going back to the slide that Ryan showed, we have a lot of spare parts, and we want to make sure that we give you the right tools at the right time. So ultimately, it's about having this fast car, which is is kind of what the dream object is to get here.
So is it incremental updates to your index if you're going directly into Elasticsearch?
Yeah, it's like how you would index any document. So it's just incremental.
Does it mean that it really undoing basic filtering or perhaps?
Yeah, it does filtering, but it's filtering at the very basic level. It doesn't parse the entire message. So you can only filter by things like host name and very simple things. Because the idea is to make the beats very resource friendly. So if you parsing string, parsing using regular expressions and all these things are very expensive. So you want to make sure at your edge nodes, at your network edge nodes, people have thousands of servers, right? So we want to make sure that that part is very, very quick. Take those logs and just take those data, doesn't have to be logged, and just shove it into Elasticsearch as soon as possible.
Essentially, log forwarding.
Yeah, or Elasticsearch directly. Alright, so let's do a demo for ingest, and then this is gonna show you a lot of these concepts. I'll try to balance my typing with on the keyboard. Okay, how many people here know about Sense? Okay, so Sense is this, let's start from scratch actually. So I've installed the latest and greatest of Elastic Stack, which is 5.0 Alpha 1, which is the most recent release of Elastic. Ryan was talking about 5.0, and this is the next major version. I'm super excited about it because there's tons of new stuff. And one of them is redesigned Kibana screen. So let me start with the home screen, which is Kibana. And one of the things with Kibana is console. And you can get to console using this left-hand navigation, which is also very new. So if you use Kibana 3, Kibana 4, this thing didn't exist. This is all new, right? So you go to console, and console is the new name for Sense. Sense was basically a way to do request response and to interact with Elasticsearch, because Elasticsearch is everything's API based. Right? It's based on JSON. It's based on HTTP constructs, RESTful constructs. So you could use curl, right? Curl or any kind of request response tool like Fiddler, or you could use like your browser to send data or to get data out of Elasticsearch. Sense is a very, very nice way of doing it because it's context aware and it does autocomplete. So I can type stuff and it knows exactly how many indexes you have, and, what kind of query DSL, it knows exactly how the query appears and so on. So it's super useful. So I'm going to demo the ingest feature. So what ingest does is it's a pipeline in Elasticsearch, and when the data hits indexing, at that point, using this pipeline, you can take those logs and take those logs or any data and process those logs so that you can get structured information. Right? So this is exactly like the filter part of Logstash, which is now in the ingest. Right? So this happens before indexing. So the data reaches Elasticsearch, and before it hits the index, before it gets to the indexing part, you are pre-processing it with ingest, right? So ingest is the design of ingest. It's like a pipeline. So a pipeline has many different processors, and each processor does its own job. Like one of them may be to extract information. The other one is to add geographical information to an IP address. And maybe one processor is to delete an existing field or existing data, because let's say you have some credit card information and you accidentally send the logs to Elasticsearch, and you want to make sure that nobody else has access to it. So you want to drop that particular field. So you first extract it, and then you say, hey, this field is sensitive, it's got PII information, so I want to be able to delete it, right? So all these things used to be possible with Logstash, so we're bringing that power into Elasticsearch itself, right? So let's take a look. I'm going to start from scratch here. So hopefully hopefully the demo does cooperate here, so. Gosh. I need to start servers. Okay, so I'm gonna start Elasticsearch. And then Kibana.
While he's spinning stuff up, how many people in here are using Logstash to ingest their data? Okay. Because one of the things like I'm looking at is between beats, and I do a lot of manipulation or using the filter on my servers. So I have Logstash installed on all my instances. So I'm really looking at beats and how it fits in that file side of things, like how many, like you said, you mentioned, it's really lightweight file manipulation on it. So I'm really looking forward to the next version. I know it's going to be with that fields, but then the ability to, how can I filter going into like this ingest node? At that point, can I do a lot more mutation, a lot more ELT style before it gets into Elasticsearch.
So Elasticsearch is up. You know, I hit the API. It's fired up. So I'm gonna start from top B on mine. Wait. Yeah, wait for it. Your top B. Top B? Yeah. Okay. Start that one. Okay. So Elasticsearch is up. So what I do now is go to Kibana and go to console. This is console, and the first thing I'm going to do is logs is one of the index that I created, so I'm going to delete it. Because I want to start fresh in this demo. So this is, that's the beauty of Sense. So you get, this is all the requests that you're sending here, and this is the response that you get. Okay? Next thing I'm going to do is I'm going to use the put, HTTP put command to create a new index called logs. So it says acknowledge true, so that means the request was successful. And I have another API called cat API in Elasticsearch, which is used for debugging. It gives you a lot of information, which is very Unix friendly. So one of the APIs is indices. So it tells you how many indices are there in the system. So we just created logs, right? And then there's Kibana index, which is internally built Kibana state information. Right? So our logs is something that we just created. It's got 0 document in it. It's got some metadata. So and I have some existing stuff that we need. So this is the new construct. This is the new way of defining the ingest pipeline. So I have a special new underscore ingest endpoint, right? So this did not exist before 5.0. So it's got underscore ingest / pipeline, and then I can name my pipeline. So I call this Apache logs pipeline, right? That's the name I give. And I'm saying, hey, pipeline to parse Apache logs. And as I said, ingest is a pipeline, and it's got a bunch of different processors. The first processor that I wrote, because it's super popular, is Grok, right? So what Grok does is, Grok was something which was a Logstash filter. Jordan Sisal came up with that. It takes unstructured log and extracts information from it. So it extracts fields and a lot of good information. So here I'm saying I'm using Grok processor, and my target field, the information that I want to process or parse, is in this field called message, and the pattern is combined Apache log. The greatest thing about Grok is that it uses regular expressions, but these regular expressions is something that you don't have to write. So this is like, think of it as a library of regular expression that somebody's already written, and then you reuse it. So combined Apache log is the name of the regular expression, name of the pattern, which takes this complex Apache log line, and someone's written regular expression to extract like the host name, the date, and response code and all this stuff. So with just one line, with just one word, you're able to take all the crappy log data and then convert it into more structured format. So all this is in Elasticsearch. None of this is right now in Logstash, right? So first I need to register the pipeline, so I did that. right? So I did acknowledge, I got that, just to make sure that you believe this is a demo, so this happened. And its pipeline is there. Now that I've registered it, I'm going to do a get call. So as with everything in Elasticsearch, all the CRUD operations are supported. CRUD is create, read, update, and delete. So we can, I just created a pipeline. I'm going to read it back again. So I did a get call and get back this this pipeline that I just created. So this is the same thing that we input. Right now, this is registered in Elasticsearch. Okay, so now comes the fun part. Is I've registered a pipeline. I already have this configuration, and then I'm going to use the existing indexing API. There's no special API, but when I'm indexing it, what I'm doing is I'm saying use a pipeline called Apache Logs pipeline, just created. So use it and pre-process information before it indexes, right? So look at that message field, which we said was where we have the data, and it has this complex unstructured log data, which looks like an IP address. It's got a date in there. It's got some response code and byte information, right? So all that is there. If you have to do this by yourself, you have to write the regex for the IP address, followed by the regex for the date and regex for the the request and response and all kinds of stuff. So this is not what you want to do for every log line. So okay, so let's input this. So at this point, it's indexing it. Before indexing, it's going to do the pipeline, right? So this is the standard indexing operation. So it said that indexing is successful, and I created the first version of this document, and it was created successfully. Right? Okay, so let's make sure that I search this. I'm going to get back this, right? So look at all the structured information. So it took like this big blob of data, and it broke these things into different fields, right? Without Logstash, without any of the setup. So it's super easy to set up. Right? And it's the same construct that we were using in Logstash. It's the same kind of config language, it's the same broad pattern, everything, right? So just to show you a different way of looking at it. So if I take this off, right? I'm inserting this as a second document, right? I'm not doing any ingest, right? So I did that. I'll do search again. Look at this. This is just what I inserted because this is ID number 2. It's not structured at all, right? So you rather prefer this because with this you can do aggregation and you can do more structured searches, right? Any questions? All right, moving along. The other thing you can do with ingest is something called simulate. So simulate is also a very useful feature where you just wrote all this complex ingest configuration, and you're not ready to index it. You want to know if things are fine. So you're basically previewing the ingest itself, right? So at this point, I can take my sample document that I'm going to index, and then I'm going to run it against the ingest configuration, right? So at this point, I'm not indexing. I'm just testing myself. So let's see. So Apache logs pipeline, that's what I'm going to use. And then I'm saying underscore simulate. So I get the results back, but it's not indexed yet. If you go back to the search, it's only still 2 documents. So I didn't index yet. So, but I saw that this was successful and everything seems to be okay. So simulate is also very, very useful. All right, let's see. We do the more advanced pipeline. So what we're doing is, I think this already exists, but so here This is another ingest pipeline where I'm doing a grok. I'm extracting all the structured information from Apache. Then I'm also parsing the timestamp to make sure that it gets extracted in this particular date format, so that I normalize the timestamp. And then the other thing I'm doing is I'm converting the response field that I get from grok and from string to integer, right? So this is why. So when you extract stuff, by default it becomes a string, but I don't want that to be a string because I want to do aggregations, I want to do numerical analysis of that. So I'm converting that into integer, right? So I've set up this thing already. So what Ryan's going to do now is, you already sent data? No. So he's got FileBeat, which is running on his laptop. And let's assume that it's a machine in the data center, which is probably a very, very resource. It's a small crappy box. So he's running FileBeat on that. He's got Apache logs, which is about 300K Apache logs from 2 months ago. So he's going to ingest that into my Elasticsearch cluster here, right? You do it?
Well, first I started top beat, which is one of our other beats. So Swift goes up and does a get on cat underscore indices. You should see a new index there.
Yeah.
And now we see this top beat. So right as of like 10 seconds ago, information being captured from my machine as far as what are the running processes, CPU utilization, memory utilization, all that. So if he does a get search on that, you'll see those. So that's periodically being sent in. Because I wanted to start it because once I start injecting data, it's going to do a little bit of load on my machine. Not very much, but we should see it. So, yeah. So here's JSON documents about like Google Chrome and everything else in my machine.
Yeah, he didn't have to set up anything. All he did was install TopBeat, and he told where the location of Elasticsearch is, which is on my laptop. That's it, right? And anybody who's done top before, top is basically the Unix command. Everybody know what top is, right? So it's a Unix command that has different resource information. So it's almost like a crawler, right? Think of it as a crawler, which is, think of it as it's running TopBeat every 2 seconds or every second. And it's getting that information and sending it to Elasticsearch.
Yeah, and also when we say install, like when you unzip TopBeat, there's 2 files in it. A single binary and a configuration file. So there's no like install really. Yeah. Very simple. Okay, so now
And if you see that, you've got CPU, start time. This is all from his laptop, right? It's got his memory, and he's using Google Chrome, which is one of the processes, and so on, and the PID of that, and all tons of good information.
all the network scanners I'm running on.
Yeah, and all the
guest network you guys are all connected to.
all the torrents that,
Yeah, torrents.
all the download stuff.
Okay, so now I'm going to start FileBeat as I mentioned. And there it goes. So if you look at the indices again, you should now see some more data coming in. Yeah, try it again. Oh, where's the store of the file? I've got to remove the .file piece.
Yeah, so we were running this demo before. So what FileBeat does, it tracks the information, the state, right? As you write the files, as you add more information to the file, it keeps tracks of it. So you don't have to process the same data again, right? It's like a cursor in your database. So we were doing this demo before just to make sure that everything works fine. So he started at a place where there were no more new lines being added. So that's why no new lines were being added now. So it's going to delete them. Yeah.
But if you add a line to the file, then it would only consume the new line?
Correct.
Or the whole file?
It only consumes a new line.
Just the new one that was
It
added.
seemed like it would start from the beginning of the file every time you added a line.
No, it maintains the position how far it's read.
Something funny.
Yeah. Okay. Right, now we're going.
There you go. This is our view index that was not existent before. And if you see the date format, it was just created today, and this is where all the how many documents we have? Like 9,000 documents. You'll see.
And it's using the same syntax that, yeah, over 53,000 already. It's using the same syntax that's going to show before when he manually adjusted there. So it's adding on the query parameter of the pipeline name.
Yeah,
If you get it down there.
it's doing exactly this same thing.
Yeah, that was what we had to do. Pipeline equals, yeah.
So it's just doing the same thing. Yeah. So it's sending all the information before it hits the index. We pre-processing, parsing all the stuff, and then okay. So no involvement for Logstash or any of your custom code or anything. It's just straight and easy. Got some logs in the file. Just wants to ingest it. While it's ingesting, it wants to pre-process it. Right? And as I said, the same amount of filters that you have in Logstash, all those filters, not all actually, that was wrong. Not all, but the most popular ones that we want to have in Elasticsearch, so it makes it easy for you to ingest.
Fair question. So basically, the way I do my log stash, I have the filter and it's based off of type. So essentially, is the Apache logs pipeline by type, and anything comes in and then before it goes to that next. And then I can.
This is my type.
So then we can have like multiple types going into the same index. So if I did it more by like system or like I have an ad service system that has multiple types of logs coming into it, I could all put all in the same index.
Yeah, you can do that. You can have multiple types of index, or you can have multiple indexes. Each one with its own type.
It's done, so if you hit the endpoint again, you should see 300,000 or 299.
There you go. Yeah, perfect. So all the logs are existed. So let's go to Kibana now, which is their UI. So if you see that, this is the stuff that we just ingested. And if you see, it's coming from DJ Shmi, that's his host name. So we're not making this stuff up. And if you see that all this client IP, the HTTP version, the request response, everything is cleanly parsed, right? It's really nicely parsed so that you can now go and do more analysis of that. So one of the analysis that we're going to do is, if you go to the visualize part, this is something that I just created. What I'm doing is I'm creating a pie chart, right? Everybody loves a pie chart, of client IP addresses. So we want to find out which IP addresses are most popular. So it seems like the green one is 177.135. So this is really, really simple. So once we have the structured data, the possibilities are endless. All the features in Elasticsearch, aggregations, and structured search, all of this stuff. Yeah.
Can the big output goes to Logstash for the computation?
Yeah. Exactly. We can do that. So bees can write directly to Elasticsearch, or it can write into Logstash. It's got a proprietary. When I say proprietary, it's a format that we wrote. It's called Lumberjack format, or the Beats format right now. So it understands the information transmitted from Beats to Logstash, and then you can do whatever you want with Logstash, extra processing, extra stuff, and then send it into Elasticsearch.
Another question I have is previously a lot of computing nodes were just doing a lot of processing, and they were just thinking of more of stuff structuring required information. Now with this model, are we not loading anything in Elasticsearch?
Yeah, that's a great point. We potentially can. So that's why in the Elasticsearch YAML, this is the configuration file for Elasticsearch. I can do this. Right? So I can do no dot ingest is false, then this particular instance will not participate in any ingest. So you can have like a 16-node cluster, and then you can have 20 of these more powerful boxes to be just ingest, right? You can do no dot ingest equals true, and only they will participate in the index.
I was talking.
All right, I think that was.
You want to fire back to the top beat?
Okay, I need to ingest the copy.
All you need is just again. So yeah, I'll talk here. So remember before I started ingesting the log data that we're looking at right here on the visualization, I also started up top beat, that was collecting the CPU metrics. Well, that data is going in there, and Beats did a lot of pre-made Kibana dashboards to sort of get you started. So they have maintained a GitHub repo. It's Beats dashboards, and we have a shell script you can run, and it basically shoves all these dashboards into that .kibana index. The .kibana index just holds JSON files that are descriptors for the dashboards that you build in Kibana. So now that we have those loaded, we can go and load a dashboard in Kibana to look at our top data. And we should hopefully see a breakdown of the processes, which one of the biggest ones, etc. Oh, we need set up the top text pattern. Oh, time picker. There it is. Yeah. We'll do last 30 minutes. That should get it. Your go.
Oh, it's getting the.
Yeah, you need the topic set up. It's fine. You hit this is packaging dashboard. No topic. Load. There we go. Okay. Sorry. So this UI is hot off the press. So sometimes we're going to.
Yeah, this is just new. This is like 3 quarters ago.
Yeah, we actually on the Uber on the way here, we tethered to my phone and we like.
Thanks to LA traffic.
Yeah, we downloaded
Demo was
one of
fun.
the latest snapshot builds because we want to show you some of the newest stuff. So.
As I said, it's preloaded data. This is like something that you can just drop into your production system. It's all ready to go.
Yeah, so this is like a dashboard that we pre-built to sort of give you some brainstorming on like what a dashboard about the metrics of all the servers in your data center might look like. So top processes, all the hosts. The graph on the right is not very interesting because it's only one machine right now. My CPU process. Apparently Slack is using a lot of CPU. And this would have been dramatically different, if I would see file being running there. So yeah.
What audio was that?
I have no idea.
It's a crawler on here.
It's a good name for that network scanner software, right? Yeah. So you can see a breakdown of all this.
This visualization. Oh, good stuff. Do you have anything else to show?
No, just Q&A.
All right.
Do you currently have anything established on just emails?
Just emails? No, we don't have any out of the box like custom solution for email.
So basically you have to write your own beat for like say over email file.
Yeah, at that point, so this is the difference between Beat and Logstash and custom code. Think of Beat as it's a collector, and you have local stuff which is like constantly changing metrics information and process information. So for email server, I don't know if I would write a Beat. I would probably write like custom Logstash. Is it a cloud provider? Is
Is
it
it like from, Mailman, is it from, Exchange, is it from, like, where?
This would be on like sitting on the cloud, server cloud.
Yeah, look, there's a Logstash IMAP input, so you can tell what the config for the IMAP server is. It'll-
That exists already. Yeah, sorry, I didn't know, like, you're trying to read it from a proprietary email format on a specific email server. You had already exported payload files from an email server, If you do, just sorry, real quick, no, never mind, that's not.
I have a couple of questions. One is, we can talk about ingestion from the JDBC source. The other one, how do you make sure that your ingestion is as slow as possible?
As slow as possible?
I mean, how do you make it fast?
Oh, how you make it fast? Okay. I thought you wanted
What
slow.
are the mistakes that you?
Oh, okay. That's a new request. The first question is JDBC, right? You want to connect to a JDBC source. There's a Logstash input, JDBC input for that. You can use that, or you can create your own JDBC connector using custom Java app and stuff like that.
Nothing in the index?
So here, okay.
Yeah, it's just not gonna reach out.
Ingest is always sitting in Elasticsearch, is waiting for data to come to it. And it's called ingest. I think we're bad at names again. So it's a processor. It's not reaching out to get information. So something has to feed it.
So Elasticsearch used to have something called rivers.
Yours, yeah.
Okay, and rivers were removed. The rivers were a way Elasticsearch itself would like reach out to other systems and pull data in. And that's not something you want your like persistence engine to do. It was one of probably the premier headaches for the support team as well. We saw lots of people having problems. So it's important with ingest that we make sure that we don't cross the line back over into the river world. So ingest will always do processing, manipulation, transformation of the data provided to it, but only with local resources on the machine. As far as it reaching out to other services, that's something that we would never build into the ingest pipeline ourselves or suggest that you would use in there.
That's why Beats and Logstash exist. They are separate companies, they live on different servers. They can send data into Elasticsearch, and ingest is basically going to intercept that information.
Yeah, and most, just if you have to live in the security world and go through audits, most security auditors would frown down upon the servers that hosting or storing your data reaching out to other systems. Usually the database servers, persistent servers are firewalled off and aren't allowed to contact out because it's a hole for data leakage.
Will that induce latency to the system if you were
Sure.
going out to it?
Yeah.
To other.
I mean, I'll take, one service all of a sudden is having problems you're reaching, and all of a sudden your indexing goes.
And then just stop, or,
Yeah.
okay.
So, I mean, we can't stop you. You can write plugins, you can do your own stuff with this, but we would never show pipeline processor engines ourselves that did that.
Good question. Any other questions about Elasticsearch overall, or?
Yeah, anything in general.
What are the mistakes to make it slow?
Oh, the ingest slow? Well, if you reach out to external services.
Yeah. Just put a sleep in there.
Regular expressions, right? They are the best and worst thing. So with a lot of these processing pipelines, you'll have the ability to probably put a regex in to do manipulation. And if you make a super complex one, then it has the potential to make it slow.
Anything in the index itself should be avoided.
There's tons of ways to make it slow. Because it depends on your data, if you're doing complex indexing, complex, if you have bad hardware,
systems, when I was ingesting that log data to Stuart's laptop, FileBeat and Logstash both use the bulk API for sending data to Elasticsearch. And if you are really doing lots of documents at once, not like a user clicks a button on the UI screen and we index documents, but sort of bulk ingestion like that, you definitely want to make sure to use the bulk API. The bulk API is essentially for you to send like 1,000. I was sending 2,048 documents in one HTTP call, as opposed to 2,048 individual HTTP request responses to Elasticsearch. You not only do you gain, you reduce the overhead of the HTTP connection overflows, but Elasticsearch itself can do a lot of optimizations and bulk requests, and it can firewall off in parallel.
So we have the Grok path. Can you create your own custom like you can in Logstash? And then it's funny because these guys are going through the simulation. Typically what I would do is, well, exactly. I would essentially, I work on the DevOps. I run the DevOps organization, so as we have new systems coming out, I'll log them. Typically, I would log onto the server, run Logstash, and just send, and I'll just stand it up. Before I would send it to Elasticsearch, because it's always the, you don't want the bad data into your index and how you manage your index at that point. So it's actually pretty interesting seeing the way they do that simulation, and then, essentially they can have a log send it and then look at it, and then if you can still use the begin at files and go delete the file that I've already processed, reset Logstash or beats whatever, and then reprocess the complete log. Once I have it, it's good. That's pretty cool.
How do people like the new UI? Good? That's part of the press.
One more question. If you have an existing index, how can you apply the further filtering on the existing index? It has to be only images, or you can apply this graph filtering on the existing index?
Okay, so that's a good question. So once your data is in Elasticsearch, Elasticsearch is, think of it as an immutable data store. You can change it, but when we change it, we mean that we have to re-index it. That's the process we call it, right? You have to take that information. So there's no in-place update in Elasticsearch. Take the information, we delete it, and then we create a new document. Right? So, see, recently in 2.3 we introduced a re-indexing API. So with re-indexing API, what you can do is you can tell it, this is the source index, this is where my source documents are, this is my target index, right? And with this, you can kind of use the ingest API with re-index API, right? So you're creating this powerful, where you take the existing data, it's reading from that, it's running the ingest stuff, right? You're transforming it, you're writing it back again into Elasticsearch.
Upload general availability release for
One is upload rate to 5.0 release.
Upload rate of priorities? It depends on the alphas that we release. The plan is to release it sometime in the summer. And obviously, we'll have a couple more alphas, betas. I want to make sure that things are solid.
Yeah, we have Alpha 1 right now. There will be betas, and then there'll be the GA. If we had an actual internal thing, we would tell you.
Yeah.
But we don't. So,
Especially with fires, it's super new.
Oh, 100% there. Yeah.
Summer.
Whether it's like middle of summer, end of summer, that's the.
Summer in South America.
Yeah.
Next.
October is still summer, right?
Yeah.
So there's a lot of new, improvements in the look and feel and features, but about performance or performance.
Absolutely. Performance where in different parts of the stack, right? I mean, I didn't go for half a day. So, let me talk about Logstash and beats and then. Okay, so Logstash itself, we've rewritten some of the concept, well, some of the like most critical part of Logstash in Java. One of the things we've done is there's an event data structure, which is really great because that's what flows through the pipeline. Logstash is written in JRuby, but we've seen that if we capture the data, make it into Java, and if you use that as the data flows through the pipeline into Elasticsearch, it brings you like almost 10x in some cases improvement. So that's a scorcher. That's a really good win. And Beats itself, I mean, Beats has been it is ridiculously fast because it's doing just one thing, which is from your edge nodes. The good thing about Beats is you have stuff like filtering. If you use filtering, it's going to slow stuff down. If you don't, then it's going to be as fast as possible. And I don't know much about Kibana, but Elasticsearch.
It's a UI, it's always going to be slow. Kibana's itself has never been usually like a performance bottleneck. It's always been how it organizes the search as it fires off to Elasticsearch.
It's bad reputation because it's thinner.
This, yeah. So it's one of those things, right? It fires actually off an M search, which is a multiple search. So one HTTP call, but it actually executes lots and lots and lots of searches. I know they've done some stuff to say, okay, instead of just like firing off one M search, let's fire off maybe 3 M searches, because you remember back in the day, like browsers notoriously handled like IMG tags, like terrible, and like if you have the wrong order of things, then it waits for everything to load. It's like, it'll just browser hell, right? So they've been looking a lot at to say, can we get back certain pieces of the dashboards, visualizations, etc., to try to help at least make it feel like it's faster too. Did you finish with the other stuff? Okay. On the Elasticsearch side, one thing I would highly suggest, so Jason Tito, one of our engineers on the core ES team, gave a talk at Elasticon about like resiliency and all the stuff we did internally in Elasticsearch to like avoid all these like super edge cases that will either slow things down or maybe cause an error, cause an index to fail or get in a bad state. That video is out there. He talks for 45 to 50 minutes on that, so it's a good one. One of the ones I'm the most excited about is we don't have a name for it yet, so I'm going to call it what we sort of internally say, which is we now can internally rewrite search requests. So one of the things we've always leveraged in Elasticsearch and Lucene is that Lucene writes immutable inverted indices. So once we write an inverted index, which is what the search is, we never go back and update it, touch it, etc. So we can leverage caches of these, and we bit set caches for a filter. A very common filter, especially for Kibana, is like only show me things for the last 24 hours or the last 7 days. And you use date math expressions for that, now minus 30 days. So filter bit sets allow us to basically cache and say, does this document match or not match the query? And once we build these caches, since the segment files, which are the immutable inverted indices behind the scenes, since we don't change it, once we build the cache, we don't have to worry about, do we need to update it, right? If we delete the segment, we delete the cache. I know this is a long story, but it's still a point. So we don't cache now, like, because, well, I feel like I'm in the quote Spaceballs movie, but when are we going to get to now? Now. What is now? Then? When is when? Right? We don't cache now because it's constantly changing. So now minus 30 days, we didn't really cache. We now are able to finally get to a point where we can rewrite search requests so that all that is cached. and it has an blazing impact on the speed of Kibana, especially if you're searching over like 30 days worth of data, maybe a couple billion, 50 billion documents. You would have seen the top grid of the date histogram sort of like chunk in. It just like pops in now because of that, because of those caches. So I'm really excited about that one.
How's that tie into optimization? The index optimization?
It doesn't, that has, what I just talked about has zero impact on indexing speed. It does not. Yeah, there's no zero impact on that because it's all how we're managing the caches. What else? 2.x did a lot. 5, we did a lot of performance. Oh, Geo is getting way faster. For a long time, Geo sort of was like the feature in Elasticsearch that it was there, but it sort of got, okay, who's got Geo for the next 6 months? Okay, you do, who's got Geo for the next 6 months? Oh, you do? So one of our engineers, Nick, has basically been dedicated on Geo for a year and a half now or something. And he's making a lot of core contributions to Geo functionality in Lucene and Elasticsearch. And we have a bunch of Geo improvements that have been incrementally happening, and they're going to happen with we have a new data type for Geo. So basically we got to the point where we could only optimize the old Geo point type. When I say type, like string, date, integer, etc., we had a Geo point type. And we optimized it only to the point where we could get it so fast without fundamentally changing how we persisted in Lucene. So the new Geo point 2 coming is based off of BKB trees in Lucene, and the Geo 2 is going to use that, which is going to hopefully really take the Geo to the next level, because I know that's important for a lot of people.
Any more questions at all? Or can I ask how many people are on free Elasticsearch V1X? How many people on 2X?
Running off my head.
You guys?
Who's running off master?
No, I'm still, I guess I think about my strategy too. I'm still 1.72, I believe. So now I guess I think about V2. But these guys start talking V5, I'm like, man, I gotta keep up. Like, I'm running the meetup. It's like, making me look bad. But there is definitely, what I really like about Elasticsearch is the ability, you really can tune in and really take advantage of snapshots. But I am running log stash data, so I have a daily index, and essentially every night I'm cutting off and throwing up data in S3. So I'm definitely thinking about the ways to kind of mix and match, and I really look forward to getting more into beats, but I got to figure out how I'm really it's going to be a big architecture change for the way I process data now. So it's going to be very interesting now, but I'm looking forward to taking on some of those challenges.
You just reminded me of something. Yeah. So if you are interested, because it seems like the interest in the programming in the language Go is constantly like growing. If you're interested in trying to write your own beat, we recently released a beat generator. If you type like beat generator Elasticsearch, it should be the top you'll get. It's a blog post from Tudor. So I mentioned Tudor and Monaco were the German team that did Packet Beat originally. They basically wrote a generator so you can just execute it, and it basically makes you a repo and a file system structure and everything. So it's like, ideally it's like, okay, put your code here, register your name here, do all this here, so you can get started with it really quickly. So if you're interested, that's a really cool way to start with it. When you said, I want to get into the beat,
No, I definitely do. I think the parts that miss it for me is I do a lot, I like spreading out the index across all the servers. So it's going to be very different the way I do it now. We run our infrastructure in AWS, so the stuff I capture all the instance information in my log as a process. So I do a lot of notation as the logs come through. So that's the part I want to go add and file being copy. Essentially, I'm using Gangly right now for my top beat, which could be replaced by top beat. So, but it's definitely, it depends where you are within your the evolution of what you've been using, the whole EOK and now Elasticsearch. So next Wednesday is the meetup. It's going to be in Ticketmaster in Hollywood. I'd love to see you guys come out. Hopefully we might have someone from Ticketmaster actually speaking there, so hopefully I'll finalize that tomorrow.
Okay. My other arm is broken here. It's fixed now. Okay. So, as Rich alluded to earlier, we recently, the Elastic, had our annual user conference. It's held out in San Francisco. It was in about the middle of February, and we had a bunch of announcements about the Elastic Stack and stuff. So we thought we'd give you a quick recap on that, and then Suyog is going to come up and going to go into one of the new features we announced there, and we're going to do a live demo. He's going to show you some stuff. I'm going to ingest data from my laptop into his laptop. Hopefully the demo gods will be good to us today. So just in case everyone's not clear, because I think there were a lot of people who are either just starting or new to the Elastic Stack in general. Commonly prior to this, you might have heard it called the ELK stack, ELK. It sort of was a self-named thing because Shai, our CTO and founder of Elasticsearch, never wrote Elasticsearch to be used for logs. He just wrote it to be used for full-text search. And then we had Rashid and Jordan came along, and each independently. Jordan wrote Logstash, Rashid wrote Kibana, and they sort of became a nice, loosely coupled set of tools that work well together for the logging case. Well, as all three of those open source projects came together under one company called Elastic, we started to add other products to the family, such as Beats. We have a sticker. Beats, which is lightweight log shippers. So there are a bunch of shippers. Packet Beat, which looks at packet data on your computer. Top Beat, which does like CPU process information. WinLog Beat, which can listen to Windows event log messages. File Beat, which can tail files, etc. We also have our cloud, which used to be called Found, and that was Elasticsearch as a service. So the whole ELK did not really work well for us anymore. So instead of the ELK stack, we decided the Elastic stack makes more sense as we have all of our new icons here and logos, and as we hopefully add more to the open source stack as things go on. So new logos and everything, but the ELK is still there, but we have a DNC now. So Elastic stack. And we have hot stickers too. So on the Elasticsearch side, what's been going on with it? So Elasticsearch started out in the 0.1 kind of era for a long time, and when it graduated to 1.0, it was a big step. And then
my experience with Elasticsearch and Logstash was back before Logstash was suggesting Elasticsearch as the primary backend. But right now we use it every day for the last few years in production. We do all our application logs in there. We don't do the deployment without seeing the metrics of how the application is performing once it goes into production.
Hey everyone, my name is Suyo Grau. I work at Elastic as an engineer. I primarily work with Logstash, but I do many of training and we had training this week in LA, so we're going here. Thanks for coming. We're going to talk about a bunch of stuff that happened in the user conference in February, and also new ways to get data into Elasticsearch. So my partner in crime is Ryan.
Hey, Ryan with Elastic, based out of New York. And on the education team, so I do a lot of the training, prepare a lot of the material that we do when we go from city to city and deliver the trainings. Prior to Elastic, I was a Java engineer for about 12 years, and companies minus ago used Elastic and the Elastic Stack for both logging and full text search in the applications I built, and I liked it so much that I joined and I'm here now. So definitely a fan prior.
All right, and this is a special meeting because Elasticsearch, Elastic is in town and training to try to do some type of meetup. So the regular meetups is the third Wednesday of every month. Next week is going to be in Hollywood, Ticketmaster, and this year what I started doing was East Side, West Side. So this month will be East Side, next month will be West Side. We go back and forth. And you guys can travel back and forth across the city if you want, but I'm really trying to build up a strong user base in Los Angeles. And that means not just always doing all our meetups in Santa Monica or Culver City or on the West Side. So I think I might have a speaker for next week, but definitely come out and join the fun. Then we also have the third week of May. I don't think it's not the 20th. I'm actually going to mistake there. So most likely we're looking at riot games over here and also in Santa Monica area. So definitely check out the meetups. I have every meetup scheduled for the rest of the year. So feel free to sign up. Also, people mentioned personal projects. I would love to just do a meetup talking about personal projects with Elasticsearch. I have a few that I want to kick off this year. I think I'll finally have time to do. So, if you're interested, it doesn't always have to be all business, but if there's any personal things you guys do with Elasticsearch, I'd love to have a meetup around that. So, keep it in mind. I'm always looking for speakers. Hey everyone, my name is Rich Horace. I'm the organizer of LA Elastic Music Group. And basically, tonight we're going to have a couple guys from Elastic present on new ways to get data into Elasticsearch. And we're going to also talk about some of the announcements from February's user conference. Did anyone here go to the Elastic conference? It was definitely a lot of good stuff presented and a lot of new logos, as you see from the new stickers here. But tonight I'm really looking forward to this presentation. But the way I like to do my meetup is I like to have everyone go around the room and introduce themselves. Let us know what you're doing with Elasticsearch. If you're using the whole PLK stack, how long you're using it, it's in production. Just do a quick introduction and stuff. So on you.
My name is Joshua. I am a Ruby on Rails developer. I've been developing quite a year. I just used Elasticsearch. I just found out about it the first time a couple weeks ago. I'm making a practice app. I thought it was really, really cool.
is just a hit, and the software here and the shooting about it is it's organization. We're using it to build APIs on top of it to access our data. It's really interesting from a personal project standpoint. Do some things with Elasticsearch as part of the data pipeline, data pipeline for natural language analysis. It's really neat. The new network graph was released. It's really so I like to do some more stuff with that, map relationships, natural language, do articles, and then articles. I'm 211 on that. 211.
Hey everyone, this is Wayne. I'm a software engineer. I use Python and I use Elasticsearch for personal log data and working on the analytics. It's great for you guys to
Hey, I'm Bobby. I've only slightly touched Elasticsearch. I just read it in because it looks something like it's really interesting, something I want to dig a little deeper in.
My name's Alfred, full stack developer, mostly in Python code. I'm actually an angle, just like kind of sitting and see what you guys kind of say and talk about. I really touched Elasticsearch a bit as well, but yeah, mostly here just to see the presentation.
My name is Johnny. I'm a software developer at Disney. Now we're using Elasticsearch, so it's just
Bigger, accessibility, finding a little bit of the rest of
Year, 2.0 came out, and that was another big step. And a lot of that was sort of just getting a lot of features in, sort of we moved from facets to aggregations, we put in backup strategies in a snapshot restore in 1.x, a bunch of stuff like this, but basically what we've been featuring, focusing on lately is a lot of resiliency, stability, and sort of hardening of Elasticsearch itself. So hopefully see a pattern in our release notes as they come out, that we're doing things that, for example, really drive down the amount of heap usage, Java heap, that Elasticsearch needs. This has been done with doc values and a bunch of other features we have. And our goal is to eventually make it essentially so, like, long term, the Java heap is not a scaling factor at all for how much data a node can support. So the team is working very hard on that. And also a lot of stuff with security. So things just such as like out of the box default settings to a new scripting language that's coming out called Painless that is completely sandboxed. Has a lot of sort of checks in it to make sure that you don't accidentally shoot yourself in the foot and get yourself into a scenario where a document that has the right kind of data in the field or missing data sends something off into an infinite loop or something like that. And then we've done a lot of work on the security side in our commercial product line for things just past username and password authentication, but down into like role-based authentication and field and document level security. Stuff that's really, really hard to do in search. And actually Igor and Jay, both on the team, did a wonderful talk about that at Elasticon, and all of the Elasticon videos are now up online. You can watch for free. So if you're interested in how you do that secure search, they have a talk up on there. So then next up with Logstash. Logstash, has really grown over the years to just be a amazing Swiss Army knife. Typically people use it with Elasticsearch, but there's many people who use it and don't even use Elasticsearch because you don't have to. And it's also wonderful when you want to ship data to multiple sources. So not just Elasticsearch, but let me ship my data parallel into S3, into Elasticsearch, and maybe somewhere else. So Logstash is got the very, very big plugin architecture, but once it gets into ES, we have all the other features that we have coming along with it in our commercial pack. And Logstash is basically going to be, we have clustering capabilities, automatic file reloading, and a bunch of other features that Suyag, who's on the team and much more intimate to it than I am, tell you about. But basically trying to make it so that people who are running very large Logstash deployments have a better way to manage those, config management, etc. So, information.
Hi, I'm Henry Pack. I just actually joined last week as an essay in the Los Angeles area, Southern California region. So if you guys have any questions, as engineers, I guess I'll talk about it, just mind, feel free to contact me or talk to me afterwards.
Hey guys, my name's Dan, CPO at a startup called FAPL, and we just started incorporating Elasticsearch to our search functionality, and just looking for new ways to incorporate it into our stack.
Hi everybody, I'm Brandon, also at FAPL, full stack engineer, and I'm looking to learn more about Elastic so I can work with it on the stack as well as in my personal projects.
Hi, my name is John Nolan. I'm with Boardwalk Studios. Elasticsearch is something new to us, so it's something I'm trying to get up to speed on.
Hey, my name is William. I'm a system engineer at Qualifier. We use Elasticsearch for logging and for storage of text messages, searching for text messages. So I'm not directly involved in the development of it, but I need to be able to support it. So I'm just kind of learning more about Elasticsearch to see how other people use it and share more stories.
I am Karthik from Verizon Distributed Services. Some of the teams in our company use Elasticsearch for things such as DDoS protection, layer 7 activation and stuff like that.
Hi, my name is Carl. I'm with USC. There's a master program for data science and spatial data science. So basically, it's a lot of data science stuff.
My name is Ed. I'm right now working on an app for the Chinese market. So we're planning to use Elasticsearch to search a lot of Chinese text, and I hope it works. I'm not familiar about how it works in Chinese.
Hi, this is Rudy. I'm working with Symantec. We've been using Elastic for about 3 years now. And I work on the platform data engineering.
Hi, I'm David Cesar. I work at UCLA. We're doing more of these software.
Hi, my name is Benjamin Nussbaum, CTO at Pipeline. We've been deploying Elasticsearch in production for a little over 3 years now, since we're deploying it.
Hi, my name is Josie. I'm an IT consultant learning about Elasticsearch.
Hey, my name is Hudson. I'm a software engineer at Vesves. We use Elasticsearch mainly for reports and logging.
EG also from Vesves and reports like